seats on that later. Okay, can you hear me now? Ah, that's better. Well, I make it 6 o'clock, so those who have just come in, levitate or sit down. Yep, you too. Prizes will be awarded for the best yoga position. Okay, so we're going to start. What am I going to talk about? Well, it's immensely boring, so I hope you all brought your pillows. We're going to cover Solaris 10 and at least 2 of its better points. Solaris has improved since the animal most of us know and hate. We're going to look at dtrace, which some of you will hopefully have heard about. I think some have probably spent far too much money publicizing it, so if we haven't heard about it, that's their loss. We're also going to look at the modular debugger. We're going to look at rootkits, the current situation, and what I see would be useful for the future. We have some fairly knowledgeable people in the audience, so I'll be careful where I tread on that. We're going to look at Sinner, which is the Solaris rootkit, which, if any of you have visited rootkit.com in the last hour and a half, is now posted. Those of you with net connection, I'll see you online. We'll have an introduction to it. We'll look at some of the development stages, namely where I kept crashing my machine. And then we're going to, well, I'll give you the URL of the finished product. So, what isn't this? Well, even though the EU may be trying, this is not yet illegal. It's not a bug disclosure. Sun and I are both fairly keen to get that one across. That's the only stipulation of any of us seeing this, is that I show it's not a remote root or a local root vulnerability in Solaris. I'm not going to read code to you. If you can't read English, that's your own problem. And I can't think of anything more boring than me standing up here and reading C for an hour, or even D. It's not anti-Sun. Sun were given an opportunity several months ago now to veto it. It wouldn't have happened, but they could have tried. So we'll just leave them all alone. They've been very friendly as far as the whole project's concerned. They haven't answered very many questions, like none, but they're good anyway. And nor am I going to give the whole thing away. I know this has been publicized that I'll be hiding sockets and I'm going to be hiding files. I'm not going to do that, and I'll tell you why later. Okay, so Solaris 10. Some have this 10-point benefit list. I have a 4-point. Choose whichever one you want to read. Solaris 10 is very, very good. It only crashes occasionally, namely when I'm doing things wrong. But as far as the benefits go of running Solaris 10, you get this very, very cool piece of software now called dtrace. And you'll see why I think it's cool later. And any Solaris admins out there will probably already think it's pretty cool and have a dtrace addict t-shirt. We're going to look at MDB, the modular debugger, in kernel mode. Not in depth, nor am I going to show you dtrace in depth for that matter, but the ability of having, by default, live kernel debugging. For any of you who ever have to worry about kernel code, you'll probably understand why it's a bit of a blessing. I'd like to have covered Solaris zones and not laugh too hard at IP filtering, but Solaris zones is a very good thing, and I will also say why in a second. IP filtering, well, hopefully most of you know what an IP filter is. The finer points, well, yes, dtrace has far too many probes to talk about, and we're not talking Cartman or Kenny style. Over 30,000 active by default, and that's before you start running software on top of it. So, yeah, if anybody ever uses all 30,000 in a D script, would you please let me know, because I think there should probably be a bottle of champagne awarded for that one. And anyone who automates that is cheating. You get more insight into any program more than you would by a debugger and looking at a core dump or connecting into the process ID, because that's fairly interfering. Dtrace is built into the kernel. Modular debugger. Well, you can see current kernel data structures, and for any of you who've ever had to unlink from a kernel module list, you'll realize that being able to trace that through is also fairly useful. There are cool features. You can print populated structures, walk linked lists, and I'm not going to read out, etc. Yep, Solaris zones, various things. Hopefully, even Lance Spitzner will be able to use a Solaris zone and stay not owned. IP filtering is intuitive, and funnily enough, it's an IP filter. There we go. So, the modular debugger, you've got all of your normal debugging stuff, or debuggerization if you're from the UK. You can use it, and I highly recommend you use it along with dtrace. There is no point trying to find a magic bullet. Most of us know lots of software vendors who sell magic bullets, and none of us buy from them. It will resolve symbols and types. If you have a core file, you can analyze the core file with type graph, which is also a very, very useful bit of kit. And then any memory leak you may have, it will tell you within fair accuracy the actual type of where the data came from in the memory leak. I don't know how many of you have had to worry about memory leaks on Solaris, but this makes life easier. Yes, you can print populated data structures, and I've already said that. You can pipe data between commands, so when you have a linked list of a couple of hundred elements, you suddenly find yourself having a much easier time because you can print the same details out for each element individually. This is a good question. What is the fuss about? Anything which runs on the Solaris 10 system, with one or two exceptions, which I'm not going into, can be probed. This is, of course, with the exception of our rootkit. You can monitor system calls, so any of you admins who have a script which goes through and dumps a system call table, MD5 checksums it and tests it later on, well, you can do this now slightly more easily, if not slightly slower. You can set probes to fire regardless of what you're looking at, so you can fire into a function on entry, as we'll see later on. You can watch the return, or you can go on an offset. So if you for you Spark people, if you look at function plus OX4, you'll find that you'll be able to watch that particular instruction. And I think that's quite useful. Yes, and the bane of our lives, as far as rootkits are concerned, is that it does dynamically create these blasted probes. It gives understanding beyond the norm. If you haven't gathered that from me by now, then you've probably either fallen asleep or can't understand English. Linux users, yes, I'm sorry, this is a fair point. I do use Linux, I like Linux, but it's a good thing about Solaris. It might get more of you to use Solaris if Linux doesn't have dtrace, or you could just port it. If you want to see what Brian Cantrill, who's one of the dtrace developers, thinks about porting Linux onto, no, that's wrong, dtrace onto Linux, it involves a middle finger. Sun, funnily enough, regardless of what any of you may believe, it is going to become open source. And I've sent, really? Yes. Really? Yes. For at least 20-odd emails over the last couple of months to Sun. And each time I said, yes, we're going open source. It did start off saying yes in 12 months. And then a month later it was yes in 12 months. So maybe in 12 months' time. Just briefly looking at dtrace. There we go. This, believe it or not, is part of a dtrace listing. More of you, the observant of you will see that it's only part of a dtrace listing. I couldn't fit 30,000 probes onto the slide. Just to have a quick task and see how these things are formed. Your dtrace code originates from your provider, your module, your function, and the name you want to probe. Why is this good? Well, I don't know, but it's also not bad. This one here will monitor the syscall exec entry. If you think about when we've hijacked exec later, you'll discover that's quite a useful thing to be able to watch, even if it won't pick it up. This is the bit where it's all going to go wrong. So this is my version of how to introduce you lot to dtrace. This is what we're going to try and analyze. For you GPG users out there on Solaris, you might recognize some of this if you read the code. As you can see, the second parameter, namely arg1, is a string. That's a plain text string, ladies and gentlemen. So, funnily enough, we're going to read that string for any user. The provider is going to be the GPG process when we run it, so we need something which is going to watch for the process to start with. I'm not going to explain the following code. If you want it explained to you, come and find me in the bar. I'm going to be there for quite a long time. That's the code. Like I said, I'm not reading it out to you. So what we're now going to do is probably crash my system. No, so far so good. Okay. What we have, this user is root. This user isn't, but could be, because he's got the rootkit installed. For the sake of this, he's not at the moment. Okay, so we decrypt our highly secret text, and I put in the password. Now, I need an agreement here that you're not going to reveal my password to everybody. As you can see, that's worked fine. For the matter of fact, so is that. There's our passphrase. Any user running GPG at any time, any passphrase. Use that as you will. I mean, you know, and you don't have to be root. If you have dtrace privileges on the system, and a lot of people are going to let people in now because they have knowledge about D, they're going to let you onto the system, and you're going to be able to use dtrace to read other people's GPG passphrases and debug the system, of course. That's the contract. Okay, back to the not quite so exciting bit. So, we've done that bit. You're all fairly happy and confident in D now? Excellent. What can we do with dtrace? Well, these are just my theories, and I've asked Sun about them, and like I said, I've only had 1 or 2 responses. A couple of them were very polite. So, we could use hidden dtrace processors. Hidden processors, would that be what you use a rootkit for? And you could watch email, web, SSH, or of course GPG for that matter. And etc. I don't know, has anyone got etc. running on their systems? You could use control statements. If we could have loops and if statements, it would mean you wouldn't need 2 dtrace scripts in order to monitor process IDs. At the moment you do, and that must add at least a second's lag. You can't really stick an infinite loop into the kernel. I hear that's a bad thing to do. So some have, for the same reason, not actually given us loops for statements and too many if statements for D. No sense of humor. Okay, limitations. Like I say, without program control statements, it's fairly automated, but it's not as good as it could be. You do need appropriate user rights. Sorry? Madam, will you ask me a question? No, okay. It's okay, go back to sleep. Okay, contraception. Well, I'm a Brit, and if any of you have seen any of the Gruggs presentations. Has anybody got a crowbar? Or a baseball bat? Or a bucket of water? Good. I think I got my point across. Okay, so in order to stop this, you could delete D from your systems and dtrace, and then basically you'd be running Solaris 9. So don't do that, because we don't want to run Solaris 9 anymore. Don't give dtrace rights out unless, you know, you've got them tied down to an NDA and their balls lined up to the chair or something. Or you can use an OS which isn't quite as cool. The choice is yours. Rootkits. Now, hopefully some of you will know what one of these is. Maybe not. Okay, well, of course, there is Linux. And there's a few for Linux. There's a door written by someone over there. And there's Suckit, which is written, and I hear there's a newer version, but from what I saw, or didn't see of the newer version, it's not a newer version. There's BSD rootkits. There may not be an awful lot of public BSD rootkits, but they must exist because BSD exists. Sorry. Some work has been done by THC on kernel rootkits. I looked at it and spent 5 minutes writing one a couple of months ago. Sorry, I looked at it in depth and spent 10 minutes writing one. There's been Solaris. THC did do one. Plasmoid wrote a paper on it. It did miss out a couple of gaping holes, like off by ones on the module list. You'll see those in a second. And of course, now there's Sinner. Apple OS X, oh dear. Yes, there has been some code posted onto Packetstorm. It's a shame the author can't write kernel code, because he's missed out some holes. For some strange reason, I don't feel qualified to talk about this one. Sinner is hosted on rootkit.com, and I am by no means the best person to tell you about Windows, because I don't use it. The future for rootkits, as far as I'm seeing it, okay, what is of interest? Well, system call modifications, yeah, you can use them. Are they boring? Yes. Has everyone done one? Yes. So there's not an awful lot of point there. The only new challenge is when they change the kernels is finding the system call table to begin with, and that's not exactly a challenge. You can look at the interrupt descriptor table or the global descriptor table. You can look at it. That's what Socket does, and you can monitor it just like you can with system call table modifications with MD5, as long as there's not too many collisions and that attack doesn't become useful. VFX hacks are still cool, and yes, he's very quiet. How to get the system call table? Well, that's not a good thing. That's better. Okay, how to get the system call table? You can use sys underscore exports, so all of your sys functions, their addresses do appear in the system call table. If you use those offset and you think it's an array, then you'll be able to find a system call table. It's not hard. There is code out there which is currently using it, some of which is based on very close friends of mine. Rootkits and injecting from shellcode, this isn't a new thing, but I think it's going to have to become more and more used. For the simple fact that people think of removing sort of mod load from the systems is going to protect them. Okay. x86 compilation. This is someone else's department. I prefer Spark. It's about 3 times the price tag, and I like posing. Moving on, because x86 compilation is a fairly specialist thing, and we could spend at least half an hour discussing it, and that would probably be all we'd want to discuss about it. Stop using clients on your rootkits, folks, because it's forensics. Forensic people love finding clients, especially, you know, they sort of spot Ava installed on the system, and they go, we know what's on there. For a laugh, if you just put Ava into your home directory at work, the security team will have a field day, even if it's not installed. Okay. Any people who are asleep, can you please poke them in the kidneys? Brilliant. What did I want to do with Sinner? Well, I wasn't actually printing it off for nefarious purposes. I wanted to write a Solaris 10 rootkit. It needed to have privilege escalation, because I did think that a rootkit without privilege escalation would just be a really boring kernel driver. Added bonuses, as far as I was concerned, was hiding processors and child processors. And you're not going to believe how easy that was. Hiding sockets. Yes, it's possible, but then again, so's not. Hiding files. I'm not going to cover hiding files for the simple fact is I don't like forensics. And I don't want anybody to know that my stuff is installed there. So if they suddenly spot a file hidden, well, yeah, the game over. And yeah, if it works, 90%, no. The actual rootkit stuff, unlinking and semi-hiding. Well, yeah, semi-hiding, we'll see why later. That's Winnie the Pooh syndrome. I am not reading that out to you. Just for note, those of you who don't recognize a linked list, guess which entry it is. And the 3 fields at the bottom, memorize those for later because we'll be using them. So, wow, wasn't that hard? Now the microphone's alive. The only problem with removing ourselves from the linked list, as you can see with extremely complicated linked list manipulation, is we get this little problem here. I don't know if those back can actually read that, but there's a little case of the fact that numbers don't go next to each other. OSX rootkit. How do we stop that? Well, what we do is we first find the system, and we look it through the kernel sims, and we find this little thing called last module ID. And funnily enough, so can dtrace, because dtrace uses the kernel symbol table. Now, dtrace can print the address of anything it can find in the kernel for you to see. The version of Sinner which was up on the internet, on rootkit, was using a similar build method, and it got all of its variables using dtrace. And then I got really, really bored of editing a build script. So it's a makefile now, folks. That's not particularly complicated, and neither is that bit. You can understand it for yourselves. And that's the result, which looks slightly more promising. For any Brits in the audience, I thought this was fairly apt. Things do have symbols. You all know why we have symbols. Mainly to be recognized. Symbols can be seen, and when you've installed a rootkit, there's something which is really, really embarrassing, and that's being spotted in the kernel symbol table. Because you'd really feel an idiot. I did. So we don't actually want to have our hijacking exec4u functions seen. So what we have to do is we dig into the kernel symbols. I detraced it, funnily enough, because it's Solaris and we have dtrace now, folks. So it turns out that there's this little function which you can dtrace called kernel sim snapshot, or ksim snapshot. You too can sex up your own dossier. Kernel symbols take its entries from any loaded module. So it's anything which is loaded. Did we all understand that bit? So when we've actually got an unloaded module, but the rootkit has been installed, so to speak, because it's unloaded, so it can't possibly be there. What we find, if we call kopt-sync, what that does, that just iterates over this list of active modules, that's loaded modules. We can't see ours anymore. And that's also vanished. Okay, we've lost a slide, but anyway, I'll tell you later. Why you, this is processes. Why you can't just remove a process? Right. How are all of you with time slicing? A process that isn't known to the system just doesn't exist. It doesn't run because the system does need to actually keep track of it because it wants to execute some code at some time. It needs to be invisible, i.e. not there, but it also needs to be running. So there is no point taking your process and removing it out of the timing system. If the scheduler can't see it, it's not a process. So, yeah, like I say, not good. However, Sun are very kind to us. Because within our process structure, we have a PID structure. And within that, we have a field which says if we are active or not. And funnily enough, can you guess what happens when we do that? So when we mark our process to be inactive, because it's not running, because it's inactive, and the field says so, it's not a process. So when we look for our process, it's not there because it's not active, as far as the code's concerned. Well, that was hard. I mean, that was really taxing. So now moving on to the bit which I imagine one or two of you may be more interested in, and that's disabling dtrace, because it's really, really good for seeing everything, but it's also not really good because you can see everything. We have these little things when we've loaded our module there. Info, which is the module info, and Sinner exec4u. We don't actually want the admin to be able to probe our rootkit, because that strikes me as being slightly dumb. Dtrace uses kernel symbols. So if you have these active and you've removed yourself from the kernel symbol table, and if anybody wants that code, they can have a copy of it by all means, because all you do is laugh at yourself for several hours, because that's a null kernel pointer. Dtrace will only probe, like I said, active modules and active providers. One solution. Oh look, are we sensing a trend? Logic is a great thing. If a module is not installed, it's not there. So, yeah, that's not there. You can still see it from dtrace-L, so you can still actually see the functions. What this does is this disables the probing of it. If you want to know the complex, in-depth, gory, extra page of removing it from the dtrace listing, buy the 21C3 conference proceedings book. Okay, it's not cheap, but do that, because my whole technical paper's in there instead of the slides. Or it's going to be on the internet, so download it off the internet. Or look at the actual code, because I'm not going to give you lot a half-botched job. I know how many sunboxes you want to have for educational use. So in the beginning was the Word, and the Word wasn't Archim, it was Spark. Liberating system calls. System calls should be free. Which libraries are you using, madam? So, the normal method, change system call table, etc. Bloody etc. crops up everywhere. So it's easy to do, it's easy to detect, it's boring, and it's been around about as long as I've been alive, actually, and that's rather depressing. 5 years it is then. You can hijack descriptor tables. That's good because, you know, your check rootkit isn't yet looking at it. Yeah, check rootkit. Don't use check rootkit, ladies and gents. It's not worth it. Too much hassle. You have to compile it. Shell scripts. It's easy to do to hijack a descriptor table, and it's easy on both x86 and on Spark systems. Right? That's not because the processor vendors actually want us to have an easy time to hijack these things. It's just that operating systems have to be able to do it, so can we. Because with the exception of maybe one larger company, most of our programs are still human. The best bit. Who here doesn't like debuggerization? This is the exec function within the kernel, using modular debugger in kernel mode. The interesting bits are the bits I've made really hard to read. No, they're the bits highlighted. I'm not going to explain that to you. So, my Return of the Jedi style. If you want to overwrite the opcodes, which is what we're going to do and is what Sinner does, you have to be able to fit your assembler in to the space, because otherwise that's going to be really stupid. Because any of you who look at the exec function, it is within the Gen Unix text space. And you might want to look at the next system call along and see, you know, if you overwrite slightly too far, it's not going to stay up for very long. Been there. Okay, so the key word here is transfer, so we're going to jump. Major shock. At this point, what we do is we pull out our very handy Spark Architectural Manual version 9 handbook. Go and buy it, unless you're really, really tight-fisted, where you can download the PDF for free. I downloaded both. Thank you, Amazon. We have to think about the, consideration-wise, we have to think about the delay slot, because RISC processors have this lovely habit of loading something you don't want them to load because you forget about it. What's going to happen with the incoming arguments of the original call? Because if you save it, you're going to have a completely separate register window going on, and then you're really stuffed. So don't save it, jump. And what you're going to return into? Well, that's all very easy. If you want the in-depth bit, look at the code. Yeah, I'm not going to explain that to you. Basically, all Spark stuff, 32 bits. This is an example of one, opcodes.h in the tarball. You've got all of the ones I use. Registers, funnily enough, there you go. There is a common misconception that you can only jump a certain distance within RISC architectures. When you read the manual, you find out that actually you can jump to the location specified by one of the registers. And registers, I believe, can hold memory addresses of most sizes. That's the structure. I'm not going to read it out. So the rest. How to insert? Well, the original one you were all going to get wrote a few things into KMem, because I'm a really boring git. We don't do that anymore. Nor do we use mmwrite, which, if someone wants to go away and look at, I'd be happy if they document it for me because I got bored. Dtrace, oh, that's another presentation. Detection of modifications. We can check some bytes, we all know we can do that. That's not new, that's granted now. We can detect with dtrace, I give the detection code at the end of the lecture. And we can use proactive security modules, or not. Deletion, well, you all know your own policy, and I'm not going to preach to you on that. But I will shoot anybody who's on the phone to me. So, for anyone who's just literally woken up, what have we looked at before we talk about questions? We've looked at some of Solaris 10. We've looked at the modular debugger. We've looked at dtrace and the GNU-PG demo. We've looked at kernel rootkits on Linux, BSD, Solaris, OS X, and something else which I couldn't possibly remember. We've looked at similar challenges. We haven't covered these things in great depth, and I will now, shortly, try and grab the slide which actually shows what to do with the active module. We have process hiding. We've desymbolized ourselves, so we're now sheep. We've looked at halting dtrace probes, the code, the paper, look at removing dtrace probes, and we've also looked at how to liberate and free our system calls. So there is only one thing left to do, but what I'd like to do is briefly flick back through my slides and see if I can find you the module stuff. Because otherwise you're all going to hate me for life. Maybe. No, I truly haven't got that there. So what we're going to do next, as will come as a huge shock to all of you, is that. Oh, well, there is that. But before we do that, we'll do that. So, any questions? And I'm told I have to throw the microphone at you. Sorry, give you the microphone.
No.
Or not.
Okay, thanks. As far as I understood, the technology behind dtrace bases on a minimal virtual machine inside the Solaris kernel. Did you manage to retrieve or reverse engineer any documentation on the instructions and binary formats and all that stuff?
Dtrace?
Of dtrace? Of
Look at the header files. They're all there.
Sorry?
Look at the dtrace header files. All the dtrace instructions.
It's on the headers? Okay, fine.
Yep, all the opcodes, all the inverted commas opcodes, because it's interpreted, for dtrace are in the dtrace header files.
Okay, great. Did you find any security holes in the VM implementation
I'm not going to
itself?
comment on that at this time.
Okay, thanks.
Next. Maybe.
If you hide processes by just setting the flag inactive.
I'm sorry, can you just speak slightly slower?
If you hide processes by just setting the flag inactive, do they also disappear from the proc file system, or are they just...
Okay, no. What does happen is you can still see your processes from two vectors, basically. You can see them from the modular debugger in kernel mode, okay, because you can see the scheduler list. Okay, like I said, process running has to be on scheduler. What happens with the process is actually really interesting, because try running check rootkit about this, because it will run away at you. They're not accessible. The entries are sort of there, but you can't stat them. And I've got no want to actually start rewriting part of the file, VFS on it. That's someone else's department. Sorry. Okay? Good. Anyone else? Well, you're all still breathing, so this is a good start. And the dust balls roll past. I'll take that as a no then. Okay, well, go get yourself an internet connection. Educational use only. There's a README, you'll love it. The license is all there. It's not exactly a big one. Slides are all over the place. They're going to be on rootkit.com by the time I've actually got back to the other side. I'm going to be in the bar. There's a change. Detection, you can detect in a whole load of ways. There's a couple of methods using dtrace, not like this, which have been found. Yeah, but they're bypassable. This is what will pick up Sinner by watching processors. This is bypassable too, but not by the code you've got.